am going to go over some problems from this worksheet, okay? And I'm going to go through 4 examples. So the first example we have is the first problem. So when we are solving double replacement reactions, the first thing we need to do is write the metal in the same place, metal being the positive one. Then we need to switch the negatively charged ions. So if SO4 is with H, that means it's going to end up with aluminum. OH is with aluminum, so it's going to end up with H. Okay, so once I do this, I got to determine my charges. Hydrogen always has a +1. Hydroxide always has a -1. Aluminum has a +3, and sulfate has a -2. You can determine these charges by looking at your periodic table. So a 1 and a 1, those are going to cancel out, okay? A 3 and a -2, we got to switch. So the 2 will come down to my aluminum, and the 3 will go to my sulfate. But I need to put my sulfate in parentheses before I can add the 3. Because if I just put the 3, it will look like I have 43 oxygens, which is just not true. So now I need to determine the states of matter. HOH is another way to say H2O. H2O is water. Water is always a liquid, so I'm going to put an L in my parentheses. Now, I need to look at my solubility rules, and I need to find SO4 on the list. So, SO4, all SO4s are soluble unless they're with these metals. Aluminum is not one of the metals that makes it a solid, so aluminum sulfate is going to be aqueous. Next, I need to balance. So 2 aluminums here. Put a 2 in front of that to make them balanced. 3 sulfates. Put a 3 here. And then a 6 in front of my water. We're balanced. We're good. We're happy. Moving on to the next example. This is the second problem on the sheet. We have barium nitrate and hydrogen phosphate. So same thing, we're going to write the metals in the same place. Then we're going to switch the negative ions. So we're switching PO4 and NO3. So if NO3 is with Ba, that means it's going to end up with hydrogen. If PO4 was with hydrogen, it's going to end up with our barium. So PO4 with our barium. Again, determine the charges. Use your periodic table for this. Okay? By now, we may have some memorized. That's okay. That will just make your life a lot easier. So, barium has a +2. Phosphate has a -3. Those do not cancel out to 0, so I have to switcheroo. So a 3 will go to my barium, and a 2 will go to my phosphate. A +1, -1, goodbye. Those cancel out to 0. So again, we need to determine, is this aqueous or is it solid? So using our solubility rules, PO4, let's search. No PO4 over here. Let's look on this side, the mainly insoluble side. All PO4s are insoluble, except those of alkali metals and ammonium. Barium is not ammonium, and it is also not an alkali metal. So this is going to be our solid. All right, now our NO3s. Let's search again. First one. All NO3s are soluble. So this will be aqueous. The next thing we have to do is balance. So 3 bariums here, add a 3. 2 phosphates here, add a 2. 2 times 3 H's gets me 6. 3 times 2 NO3s, 6. So add a 6 and we're good. We're balanced. We're happy. The other two examples, here we go. I have pulled these examples from the second page of the worksheet. I don't know what number they are exactly, but you'll be able to find them. So we have aluminum chloride and barium sulfate. Again, first thing we need to do, write the metals in the same place. And now we're switching our negative ions. So if Cl was with aluminum, it is now going to be with barium. SO4 was also, nope, not also. SO4 was with barium, so now it's going to be with aluminum. Do your charges. Again, use your periodic table to help you determine this information. So none of these charges cancel out, so everything switches. And then we just need to figure out, hey, do I have a solid or an aqueous product? So we're searching for SO4s. So let's search. All SO4s are soluble except BaSO4. Is that what we have? Nope. So we have aluminum sulfate. Aluminum is not one of the metals listed. So this is going to be an aqueous product. And now we got to look for our chlorine, our chloride. Chlorides, here we go. All chlorides are soluble except with silver, mercury, and lead. This is with barium, so this is going to be soluble. So it's going to be AQ. Uh-oh. We have 2 aqueous products. So this means that this will be no reaction. If you have 2 aqueous products, there's no reaction. Nothing will change. Everything is still dissolved in the water, so it just looks like water. Okay? Moving on to our last one. We have calcium iodide and mercury 2 nitrate. So, metals in the same place. Switch the negatively charged ions. So if iodine was with calcium, it's going to end up with mercury. Our nitrate will end up with our calcium. And we just got to check our charges. Calcium has a +2, nitrate a -1. Mercury has a +2. We know that because of this 2 right here. And then iodine has a -1. So none of these cancel, so we got to switch. Okay, and then we just have to figure out, hey, is this a solid or is it aqueous? So, finding nitrate. First one, all nitrates are soluble. So our calcium nitrate is going to be aqueous. Our iodide. Let's search. All iodides are soluble except for silver, mercury, and lead. Aha. We have HgI2. That is not soluble, so this will be our solid. Okay, so that is one of the exceptions to our solubility rules. And looking at this, we are balanced, okay? We have 2 I's, 2 I's, 2 NO3s, 2 NO3s, 1 H, 1 calcium. So we are balanced and we're good to go. I know this was a little fast, but you can pause this video at any point. And I hope this kind of clarified some double replacement reactions for you.